If you don't want to appear in the video, I would turn your camera off now. At the end of the evening, I'll talk a little bit about our upcoming meetings and may have some time just to have a general discussion if people want to hang around. But we have a rather full lineup tonight. And as many of you know, the conjunction of Jupiter and Saturn in December was the highlight. And I know many of us were out trying to see what we could see, and hopefully, we were hoping we would see it up to the closest approach. But I think the last night Betty and I saw it was the 18th, and didn't see it for 11 days after that. But anyway, pictures were online, so we could watch, see what other people took. But we have some presentations tonight of these photos as well. We're going to have a preview of the sky for January and February, and also a Comet Neowise retrospective, looking back in the summertime. And we're going to have a talk on hunting for meteorites, lessons on how you can find your own meteorite. So to start things off, Kirby Aguire is going to show us some pictures from the Jupiter-Saturn conjunction. So Kirby, if you want to bring your presentation up, please.
Okay, good evening, everybody. So just give me 1 sec to get set up here.
Yep.
Okay, can you guys see that pretty full screen?
Great.
Okay, great. So yeah, so let's start off with a little bit of completely untimely information, just so we just kind of have a little bit of perspective about how significant this conjunction was. So they call them a great conjunction whenever Jupiter and Saturn appear very close in the sky, as seen from Earth. And Jupiter takes about 12 years, almost 12 years to go around the sun. And Saturn takes about 29 years to go around the sun. And so it works out that about every 18.85 years, they appear to pass very close to each other in the sky. But some of those conjunctions, those 20-year intervals, are not very visible because they're too close to the sun to be able to see. And it might limit, you might be limited geographically depending on what part of the planet you're on as well. So they're not always visible, and they're not always crazy close. What we're really seeing is we're seeing Jupiter passing Saturn on the inside track, as seen from a platform called Earth that's passing both of them on an even more inside track. Is one way to think of it. And each successive conjunction, 20 years apart, will take place in a part of the sky that's about 117 degrees-ish different from the last one. And so we'll see a diagram on that in a minute. And then another kind of interesting fact is that about every 800 years, the Great Conjunction appears in roughly the same part of the sky. So here's a diagram that Pete Lawrence put together for Sky at Night magazine, which really summarizes a lot of those things that I just described. If we look at, and it's not to scale, of course, but here's Saturn moving along in its orbit, and here's Jupiter moving along its orbit. And if you look at this yellow line for 2020, there they were in December, very lined up together, quite close together for them, but still, of course, you know, hundreds of millions of miles apart. But if you extend that yellow line down until it intersects with Earth's orbit, you're in the month of December. And that's exactly what happened. Earth rolled in here, and about December 21st, we were looking right down that yellow line and seeing Jupiter and Saturn very, very close together in the sky. So I talked about every 20 years. So there's the yellow line for 2020, and then our year 2000, and then here's the 2021 we just passed, and here's 2040. And that kind of illustrates that 117 degree difference from one great conjunction to the next, roughly about a third of the sky in a different area. And so that's why you see these great conjunctions kind of bunched up in approximately 3 areas of the sky with that 117 degree difference. And so let's leave that one now. So here's another one. that just talked about the separation. So this orange line shows how close they were. So back in early December, they were almost 2 full degrees apart. And they got progressively closer over the month of December until they got to the closest point right around December 21st, and right around about a tenth of a degree or so. And then of course separated after that. And the blue line shows how much they were separating by, and they were getting closer at a very steady rate through all of December. And then right at that point when Earth was passing on the inside track, and we had that narrowest positioning, it kind of slowed down a little bit. Instead of like 7.5 arc minutes per day of change, it became a lot smaller for 2 or 3 days in there as they stayed real close around the 21st. And then as Earth passed by, then it went back and took a similar pattern of changing, 7.5 arc minutes per day. And now they're quite a bit further apart than they were then, of course. So here's another diagram from Pete Lawrence at Sky at Night, which is really illustrative. You can see back in October, separated by about 7 degrees, over 7 degrees in the sky, which is still, roughly in the same area of the sky, but not near as close as they would eventually get. And you can see them here getting closer and closer and closer until they were about 6 arc minutes, or about a tenth of a degree apart at the closest conjunction. And as Randy mentioned, for us here in Ontario, I think most of us, if we were all here around the conjunction time, we had good opportunities on the 17th and 18th, and then it clouded over on us, and it was cloudy through this period. And then some of us picked up, or some of the people on the line were able to pick it up a few days afterwards. But I think Ontario was pretty snowed out for the actual closest point of conjunction. So how rare was it? Well, here's one back in 1226 that was in this area of the sky, that area of longitude, and very, very close, about a third as close as the separation was only about a third of what we saw in December this time around. So this one was only 2 arc minutes apart, so extremely close and easy to see, visible. So that's about 796 years ago. So then you say, right, well, let's try to find one that's just as good as that one. And you have to go through all these ones. They're all further apart. Here's one that's not bad, 6.8 arc minutes. That was in 1563. And it was pretty visible, but that's not quite as good as the one that we just had, which got down to 6 arc minutes. So then you go, okay, well, let's go a little bit further. Here's a 5.2. That's even better than the one we just had. There's a 5.2 arc minutes in 1623, but it wasn't very visible. Must have been too close to the sun. And then you have to go all the way to the one that we just saw in 2020 at 6 arc minutes, or about a tenth of a degree, in roughly that same area of the sky. So remember, I mentioned earlier that about every 800 years, the Great Conjunction will happen in approximately the same area of the sky. So back here we are 796 years ago in that area of the sky, around 300 degrees and very tight and visible. And then here we are in that same kind of 300 degree area at 6 arc minutes, a tenth of a degree, generally visible. We had pretty good luck here, and I think it was even better maybe the further south that you went. So then you say, well, when's the next good one? So that one, you have to conclude there that the best one that was as good or better than the one we just saw and visible, you have to go back 796 years. And so that's why you kept seeing the media talk about 800 years. So if we look forward now and say, well, when's the next good one? Well, this is a pretty good one. This one is about the same as the one we just had, 6 arc minutes, maybe even just a tiny bit tighter than the one we just had. And it's going to be visible. But in astronomical terms, it's not. It's just around the corner. But in human lifetime terms, it's about 60 years away. So those of you on the line who are maybe less than 20, you should mark your calendars, and maybe you'll get lucky and be able to pick up a second really, really good Great Conjunction. But if you're like me, I don't think I'll bother setting my calendar. So photos. So I think Shakeel is going to share his photos later. I'm really looking forward to those. He did some amazing stuff, and Shakeel, I hope you'll share your close-up stuff, because I didn't do very well. I didn't even really attempt to do close-ups. So my shots are more landscape shots. This is the first one I did. I got out really December 18th and December 19th. And as Randy said, a lot of us got out on those 2 nights. Conditions were good, but it was just a few days before closest conjunction. And so here they are. This is over the Trafalgar Golf and Country Club. At that point, they were about 0.45 degrees apart. After that shot, I packed up, threw it in the car and started driving around looking for another photo op. And I started to run out of time. So I took this one the same night. Now this might be a better picture of an old barn than it is of a conjunction, but I was running out of time looking for a foreground object and finally said, well, they're sinking into the murk here, so I better just get it done. So I set up the tripod with this old barn in the foreground. This is on 6 Mile, well north of Oakville, and you can see Jupiter and Saturn there, but they are starting to sink into the murk a little bit at that point. So the next night was the 18th, and I went up the same area, really, 6 Mile north of Oakville, and took this shot. At that point, they're about 0.3 degrees separation, so they had closed in quite a bit since the previous day. And there they are, Jupiter and Saturn, just over a landscape shot. Now that same night, I did get a telescope on this. I wanted to make sure that I saw it with my own eye as well, and not just through a camera LCD. So I had my Meade ETX 90, simple little telescope with a 15mm eyepiece, and that gave me about 83 power, but it was all visible in the same field of view, which was really, really cool. As you can see, I'm a champion artist about to win all kinds of awards, but this is a page that's just recording it in my logbook. But you can see I did see with the naked eye through the telescope Jupiter, the 4 Galilean satellites, Saturn, and Titan. And then I also, right around that same time on a second tripod, I had a 400mm set up, and I didn't really do much with it. I didn't really accomplish much, I didn't think, and I didn't. But when I got home, I realized that one of my longer exposures did pick up a couple of moons. So I dragged that photo into Photoshop and cropped the hell out of it and stressed the hell out of it, and got this. And all I was trying to do, this won't compare at all to what Shakeel is going to show you, but all I was trying to do here was try to capture what I saw with the eye. And so I tried to crop it roughly the way it looked in my 15mm eyepiece when I was looking through the ETX. And you can see Io in here real tight to Jupiter and Saturn, of course, way overexposed, but Io and Europa and Ganymede and Callisto. And I think that it didn't quite pick up Titan, but I did see Titan with the naked eye. So that's my shot. You can see there's my drawing, and there's a 400mm crop like crazy. So as you can see, I am not a very good artist, but so I was glad that I at least captured that. So one of the nights when I was out, I think it was maybe it was the 16th, I tried to spot it, but the weather didn't cooperate. And I was driving home and I was thinking, you know what, I got an idea. So I have a place down in Arizona, in a dark sky site in southeast Arizona. And there is an observatory there, but it's not functional yet. We've got a lot of work to do to get that up and running fully. So I really couldn't tie into that for this conjunction. But about a year ago, when we were doing the observatories, and we put in a post with this security camera on it. It turns about 300 degrees, and we use it remotely to keep an eye on the property and keep an eye on the domes. And so this is right outside my Pass 1 observatory. And this is a shot that we took with it in the daytime of the Chiricahua Mountains right behind our property. So it's a daytime shot with that camera just to test it. But I was driving home on the 17th, I think it was, and I thought, I wonder if I went online and turned that camera to the west, would it be able to pick up the planets? And so the first night I tried that was the 16th, and to my surprise, it did pick up the planets. And the moon was out that night with a crescent moon, beautiful clear night down in Arizona. And in fact, they had clarity for about 7 or 8 nights in a row, right through the whole conjunction. So that was a great part of the world to be in, to see that conjunction. But you can see Jupiter and Saturn here being picked up by this simple camera. And this is an inset. So I'm going to show you a little series here. This is an inset. Showing, just blowing up a little bit to show the separation between them, about 0.55 degrees on that particular night. So then I thought, well, okay, that kind of worked okay. And I think it's black and white because it switches over to infrared when it gets too dark, and so that's why the sky isn't blue. So I thought, well, that was pretty easy to do. It took me 5 minutes. So I went on every night for a series of nights. So here, a couple nights later was the 19th. The picture that you saw on my cover slide was taken on the 17th. and that one was a little bit more cloudy night, but they were still visible. So here it is on the 19th, nice clear night again, and you can see they are getting tighter. And this is taken roughly at the same time. I tried to take the pictures at the same time of night every night, and you can see from the inset that they are getting closer. Would have been about 0.25 degrees on that night. Then here's the next night, the 20th, getting real close now. You can see how tight they are there, and the inset shows how tight they are. They're about 0.15 degree apart at that point. And then the last night that I did it was the closest approach, and you can see you can almost barely distinguish the two planets here visually with this kind of wide field security camera. And you can see from the inset, you know, very, very close. Actually, I think I've got that wrong. That should have been 0.1 degree, not 0.55. So that's a typo on my part. But that's where that one looked. And then when I had those four put together, I just collaged them a little bit, just to kind of slice the same section of landscape at the bottom of each of those 4 nights on the 16th, 19th, 20th, and 21st. And you can see, because I took them all at roughly the same time of night, or just a few minutes before 6 o'clock every night. So you can see that, you know, a couple of things you can see. You can see the planets getting closer and closer together, for one thing, until they're at the closest point on the 21st. And you can see a little bit of progression to the west and downward each night, which we would expect to see as those planets got closer and closer to the horizon every night. So that little collage and sequence just shows a couple of those things. So I think that's all I've got. I thank you for your time listening to me, and happy to take any easy questions, and otherwise we can move on to the next speaker.
Thanks very much, Kirby. That's excellent. Who would have thought you could use a security camera to observe the conjunction? Any questions for Kirby about his photos? I do remember seeing Jupiter and Saturn in 1980 or 1981 close together, and around I guess the turn of the century. And so yeah, so we got another 20 years to wait to see them pass again, I guess. Any other questions for Kirby? Okay, well, thanks again, and really well put together, Kirby. I really enjoy your presentation. Our next speaker is Chris Malicki, and he's going to talk about the sky for the rest of January and for February. Chris, it's all yours.
Thank you. Thank you, Randy. Thanks for having me. Okay, share screen. Okay. Can you, are you seeing my presentation? No, not yet.
You might have shared the wrong screen, Chris. Oh, there we go. Yeah, now we can see it.
Okay, slide. Okay, can you see my first slide?
Yeah, looks good.
Okay. Yeah, thank you again. So I'm going to talk about the sky for these 2 months. These are my principal references. I want to highlight the first reference there, the Observer's Handbook, the 2021 edition. I think this is a fantastic resource for everyone, for RAC members. The handbook is over 100 years old, and most of my information comes from there. And I think we should all use it, really. That's pretty well everything I've got in here is from there. And there's these other references that I've mentioned as well. The first thing, well, the first thing I should mention about observing in January and February is this comment from J. Anderson from the Observer's Handbook. February cloud amounts follow a quasi-latitudinal pattern across Canada, interrupted by the very high cloudiness over the Great Lakes. With global warming and the lakes not freezing up as much as they were before, there's even more cloud and snow as winds come through. Mean nighttime cloud cover over southern Ontario, according to J. Anderson, is between 70 and 80%. Here is a picture of my daughter's front yard in Sault Ste. Marie on a clear day. You have the sun low in the southwest. It's hazy. There's ice crystals. So even if you have a clear sky, you're going to get stuff like this in winter. So you have to take that as a caveat when I talk about observing for these 2 months. Now, we'll talk about the sun first and where it is. The Earth is on its axis 23.5 degrees. And if you take a picture of the sun every single day at exactly the same time, you get this figure of this asymmetric figure of 8 pattern. It's not just a straight line going north-south. And I gave a talk 10 years ago in February, all about the analemma. There were about 10 people there because there's a huge snowstorm. And I'm quite prepared to give that talk again if you're interested. But I won't bore you with all the reasons. But essentially, the analemma exists because of 2 reasons. The Earth's orbit is elliptical, not circular, and the Earth is tilted on its axis. So take a look here at this image on the left. There's the sun on January 1st, and here it is on February 15th. Now, if there was no analemma, just a straight line, you would expect it to go like this. So sunset is 1 hour later on February 15th than on January 1st. When I look at the numbers in the Observer's Handbook, it is obvious that 48 minutes of that is because the sun is farther north. 12 minutes is because the sun is more to the left here or farther east. So the sun is running late, 12 minutes later than it is on January 1st. That means it will set 12 minutes later than it would here, irregardless of what latitude it's at. So I got this picture. I got permission from Anthony Ayamantis. He does fantastic analemma images from Greece. I specifically asked his permission to use this picture because they've been used without his permission too many times, and I think we have to honor copyrights of people. Now we'll go to the moon. I have a very simple slide on the moon. When the ecliptic plane is tilted more to the north, the crescent moon and the first quarter moon are very favorable in the evening sky. And it's a very convenient time to look at it. And the waxing crescent is beautiful. You've got all these shadows and mountainous features on the terminator, which is the day-night side. Specifically, we have a waxing crescent like this on these 2 dates in the next 2 months. There is a lot going on in the sky all the time, and I certainly don't intend to be all-inclusive with everything that's happening. January 20th has 3 very interesting things going on. This slide specifically will talk about the occultation on that night, but also on that same day, Mars has its closest approach to Uranus, and the variable star Algol is at a minimum that evening, a very convenient time. So in any case, the first quarter moon will be near Mars, and it'll occult a 6.3 magnitude star. Now, why is this important? That's something really interesting to see. When the moon is occulting a star on its dark side, like on the unilluminated part of the moon, like you see the bright star right beside the moon, and then just suddenly it goes out. It's very dramatic to watch it. And look how convenient the time is. It's 7:14. This should be an easy event with binoculars. 1 month later, the first quarter moon is between the Hyades cluster and the Pleiades, like 2 very beautiful clusters. And it's going to occult an even brighter star, Omega 1 Tauri. This star is magnitude 5.5. It will be really easy with binoculars. And look at the convenient time. So, okay, see on my picture where it is between those clusters. Planets. Here are the 4 planets that I think are reasonable to look at during these 2 months. And my talk is essentially geared to the suburbs in Mississauga, binoculars, very simple, small telescope, a lot of it naked eye. So Mercury Just like the moon is very favorable because the ecliptic is tilted northwards, Mercury has the same favorable thing because in the northern hemisphere it's quite far north. So it's at its greatest elongation east on January 23rd. So it'll be visible shortly after sunset, and it's bright. It's magnitude minus 0.7, about as bright as Jupiter, which is magnitude minus 0.9. Jupiter and Mercury had a very close approach just a few days ago, and Jupiter could still be visible if you have binoculars, possibly naked eye, if you have a really good low horizon. I was not successful in finding Jupiter about a week ago. It's just I just have too many trees and other houses there. I thought I had a good horizon, but it should be possible. I've already shown you the image of Mars, which is south of Aries. It's also bright at magnitude 0. That's like one of the brightest stars. And Uranus is only 1.6 degrees south of Mars on January 20th. The finder charts for Uranus are in the Observer's Handbook. Should be a very easy object in binoculars, and Uranus will be especially easy to find because there's such a bright marker for it, only 1.5 degrees north of it. So that's a great, the next few days will be a great time to look for Uranus with binoculars. We just need good skies. Now, on the third event that's happening on January 20th is the minimum of Algol. Algol, the demon star, Beta Persei, the most famous eclipsing binary star, and one of the 3 most famous variable stars in the entire sky. You have a bright small star and a dim large star that partially eclipses the bright star every 2.87 days. So if you have a minimum, the next minimum will be 3 days minus 3 hours. So 3 days later, but 3 hours earlier. So if you want it to be convenient, to me, a favorable event of Algol is when it's in the evening, when it's very convenient. And it's got a very significant change in brightness, like magnitude 2.2 to 3.4. That's about 2.5 or even 3 times different. It's very obvious and naked eye. All you need is to know where Perseus is and just look. You don't need binoculars. Here's a finder chart from the American Association of Variable Star Observers. At its brightest, Algol is as bright as Gamma Andromedae, and at its faintest, it's as the brightness of Alpha Trianguli. So, like, it's probably one of the easiest estimates to make. Like, is it as bright as this one or that one, or is it in between? I should have mentioned this star has the word Algol is Arabic, so it's probably been known to the Arabs for centuries and centuries, but documentation shows that Montanari first commented on its variability, and Godric in England in 1782, he noted that it dips in bright, and so he suggested that it was due to partial eclipses, and he was correct. The partial eclipse, the eclipsing phase only lasts a few hours, so you can go about half an hour on either side of the minimum. So here, the next favorable minima in the evening. The next one is very close. It's on January 17th. Now, here's a potential experiment for all of you to do. Sky and Telescope magazine says that the next minimum will be at 11:01 p.m. on January 17th. The Observer's Handbook says that it's on January 18th at midnight 04, like 1 hour later. So the next minimum after that is 3 days later, minus 3 hours. So according to Sky and Telescope, it'll be 7:50, but the Observer's Handbook says 8:53. If it's clear, it should be very easy for us to go out naked eye and confirm who is correct. Like an hour difference will make a big difference. So I'd be really interested to know if the OH or Sky and Telescope are correct in this. Now we have of the 3 most famous variable stars, this one's in the top 3 as well. Myra, the wonderful star Omicron Ceti, a long period variable. It's easy to find now because there's Aries, Mars, and just go down and there's Myra, Omicron Ceti. This star was discovered by Fabricius in 1596, and he mentioned it or plotted it. Bayer in 1603 in his atlas logged it as magnitude 4 on his star atlas, and then it disappeared, and then it appeared again. And it became obvious over the next few years that it was cycling. Sometimes it was bright, sometimes it was faint. Normally its magnitude is 3.4 at brightness, and it goes to less than 9.3, but it can be as bright as magnitude 2. That's very, very bright. And when it's magnitude 2, it will dominate like this area here. It is the most famous long period variable, and the entire class of probably tens of thousands of LPV stars are named the Myra group from this famous one. It's an enormous, large red giant star, and it pulsates and has a dust shell. Its last maximum was in October. I looked at it on November 12th last year, and I logged it as magnitude 4.1, and I'm proud to say that when I go to the AAVSO website, that's what other people were saying, so I got it right. The AAVSO, its last observations I looked at was magnitude 6.8 on January 12th. It should be around magnitude 7 now. It'll still be easy in binoculars, and it's going to reach its minimum sometime, probably spring sometime. I don't know the exact time, but it's fading now. It's on its downward swing. I'll mention one more. This is my talk on double stars for these months. The third most famous variable star is Delta Cephei, the prototype of the Cepheid variables. It has a period of 5.33 days. It's right there in Cepheus. I'm mentioning it here under double stars because it's a wonderful binary star. My observations of it show that the bright star is yellow and the faint companion is blue. So the magnitude difference is the bright one, well, delta, of course, goes between 2.2 and 2.9, but the fainter companion is always much fainter at 7.5. And look, they're 41 arc seconds apart. That's easy to split with the smallest telescope. I have two other double stars for these 2 months, both very, very easy to find. Gamma Arietis in Aries is in the asterism of Aries, it's the fainter of the 3 stars. So it's a piece of cake to find, especially because Mars is right there. So like it's so close. It is a wonderful, beautiful pair of equal stars, like 2 equally bright stars, but they're close together. They're 7.8 seconds. So you need a telescope with probably magnification 30 or more, but you'll be rewarded by looking at this. And look at my third double that I've picked. Delta Orionis. Like, what can be easier to find than one of the belt stars of Orion, like the one on the right? It has its bright component is magnitude 2.2. Its fainter one is 6.3. But look, they're 52 seconds of arc apart. That is really, really easy to split with the smallest, like most wide angle eyepiece on the smallest telescope you can get right from the city. Now we'll go to the sky for January 18th, thanks to Sky and Telescope. So I want to point out the winter hexagon, or you could call it heptagon if you want. We'll start at Capella. That's one of the bright stars of the hexagon. Then we go to Aldebaran, that's the second one. Rigel is the third. My goodness. Yes, no, it's Procyon 4, Pollux and Castor 5. And Betelgeuse is in the middle of the hexagon. Actually, sorry, I think I've got that wrong. I think one of the corners is Sirius. Procyon, Sirius, Rigel, Aldebaran, Capella, and the 2 twin stars. So I want to point, so things to especially look for are the Pleiades and the Hyades. I've already showed them in one of the other pictures. And Betelgeuse, remember 1 year ago, Betelgeuse was at one of its dimmest ever. It was almost as dim as Bellatrix. You could barely tell the magnitude difference. And now, 1 year later, Betelgeuse is almost as bright as Rigel. It's regained all its glory. We're still waiting for its supernova. That would be spectacular, but who knows when that will be. I'm going to close off with 3 deep sky objects that we're going to look at. So basically, here's where they are, like the 3 Messier open clusters in Auriga, and of course the Orion Nebula. Like, how could we talk about the sky in January and February without talking about the Orion Nebula? My goodness. So the Orion Nebula M42, the Observer's Handbook quotes, double exclamation mark, Orion Nebula, finest in the northern sky. The Orion Nebula is not actually in the northern sky, it's south of the equator. However, it is so close to the equator that it is visible from anywhere on Earth. And the finest nebula of all, of course, is the Eta Carinae Nebula that you have to be in southern Florida or south of that to see. So from Canada, the Orion Nebula is the finest nebula. Inside the Orion Nebula is the trapezium quadruple star that you could easily split all 4 components with a small telescope. I've put down the specifications. The magnitudes 5.1, 6.7, 6.7, and 7.9. So they're all fairly close in magnitude, and they're split 8.8 seconds, 12.8, and 21.5 seconds. So it's a really beautiful sight. I'm sure most of you have seen this. There's a second double star very close to Theta 1. That's Theta 2. It's about it's 1 arc minute away from Theta 1, and it's actually a triple star with these magnitudes, and it's easy to split. No, it's not visible on this picture. It's more to the southeast, yeah, down there somewhere. So through binoculars, Theta 1 and Theta 2 make a really nice binary star, but one of the stars looks sort of fuzzy because it's actually these 4. Here's what the Orion Nebula looks like when you actually look at it through a telescope from the suburbs. On the right side here is my drawing from 1991 from Mississauga, a very quick, rough sketch. Here you see the trapezium, and there's Theta 2. This is mirror reverse, left to right, so west is to the left. This drawing on the left I made 10 years or 11 years ago, also from Mississauga. I used an oxygen 3 filter to enhance the nebulosity. So if you have a suburban sky and an O3 filter and a 3-inch refractor, you can see this from Mississauga. There's a trapezium. There's, so the double star through binoculars would be this one and this component here. It's very obvious that the Orion Nebula has a fish mouth that every visual observer mentions, a dark nebulosity sort of digs into it to making it look like a fish's mouth. And there's bat wings. With an O3 filter, you can pull out fine strands of nebulosity, like from the city even. It's so bright there, and there's the other bat wing. Truly a wonderful thing to look at through any kind of telescope. And finally, we'll get to the 3 open clusters in Auriga. I put them in this order because that's the order they are in the sky. While you're reading my descriptions at the bottom, I'm going to read out a description written by Gary Boyle in Scope magazine, February to March 2006. So Gary is writing about the winter sky. All 3 of these clusters found in the southern portion of the constellation and semi-lined up. Our first stop is M38, a wide cluster measuring about 3/4 the size of the moon. Lying close to 4,100 light years away, its stellar neighborhood measures 20 to 25 light years wide and holds 60 or so stars. M38 glows at magnitude 7.7. Moving to the lower left, we come across M36, roughly the same distance as M38. Hosting about 70 stars in a tighter 17 light-year area, its brightness is magnitude 6.3. Continuing on our course, we meet our last but not least jewel, M37, a gorgeous collection of more than 150 suns sparkling at magnitude 6.2. At an estimated distance of 4,400 light-years, this busy community is some 22 light-years wide. This cluster is superb at about 80 times and even a treat in binoculars. Thank you very much for listening to my talk. I really appreciate it. Okay, stop share.
Hey, thank you, Chris. Are there any questions for Chris? Like Swapna might have had a question.
Yeah,
Christian.
hi, Chris.
Yeah, hi.
Yeah, hi, Chris. Hey, great talk. Thank you very much. Question for you. The magnitude, I was curious how you were able to measure the star magnitude. You mentioned you had measured the magnitude of 4.1.
Oh, Omicron Ceti. I'd have to, I'd have to refer to my notes, but I was using I had a chart from Annals of the Deep Sky, and in there's a finder chart with comparison stars that you compare to. I don't, off the top of my head, remember which star I compared it to, but there is a 4.1 magnitude star close to Omicron Ceti. I'd have to look that up to give the exact answer.
Okay, thank you, Chris. I appreciate it.
Hey, Chris. How you doing? Dennis here.
Yeah, hi, Dennis.
I joined late, sorry. But you mentioned the star, the Mira variable, and you had, I think you mentioned that it was puffing its outer layers. Is that correct?
Well, it's pulsating, but it also has this very large stellar winds and a dust around it. And the star itself pulsates, and it also illuminates the dusty sphere or shell around it.
Okay, so two questions then. One is, do you think that that star is a candidate for supernova? And that's the first question. And a comment, I read an article this week regarding stars in our Milky Way galaxy and why we haven't seen more supernovas. We should have been able to see more supernovas recently, but it's been a long time. And would like to know your comment on something like that if you have it.
Okay, so Mira is not massive enough to become a supernova. Our sun will become a Mira type star. It's a red giant, but it's not a red supergiant. Those are the ones that turn supernova. Now, it is estimated that we should have about one supernova per century in the Milky Way galaxy, and really the last ones were Kepler's and Tycho's supernovas in 1600s and late 1500s. So we think that there may have been supernovas in our galaxy. We just haven't been able to see them because of dust. Maybe they were on the other side of the galaxy, or maybe it's just a statistical fluke. Like, who knows?
Sure.
But likely there would have been one.
Great presentation. Thank you.
Thank you.
Okay. Mike has written a question here. Any more info on Betelgeuse? They say it's a dust cloud eclipsing it, not that it's going to nova. Know any more about what Betelgeuse is up to, Chris?
Well, I think there was some talk that it was star spots that were causing some of the dimming. And also, yes, Betelgeuse is a supergiant, so it has very brisk stellar winds, and there's probably dust around it as well. So they think it's a combination of both more dust obscuring the star and perhaps more than usual star spots, and these two things came together at the same time. If anyone else has more comments on that, I'd welcome that, but that's my understanding of why Betelgeuse became faint, because of two things happening at the same time.
Okay. Any other questions for Chris? Okay, well, thanks again, Chris. That was excellent, really interesting. Oh, everyone's applauding. There you go. Okay, so as many of you know, Chris is, he works on the handbook, and There's some comments in the chat room how people appreciate the handbook. So thank you, Chris. I think Betty is another person who works on the handbook, and we probably have some other people around who work on the handbook. Okay, we'll move on to our next presenter, Shakeel Anwar. Shakeel, do you want to bring up your screen, please? And he's got some photos of the Jupiter-Saturn conjunction, and I also asked him if he would run his Comet Neowise retrospective that he shared with us online the other day. So it's all yours.
Thanks, Randy. Hi, everyone. So following on from Kirby's excellent presentation, I thought I'd share my experiences with the conjunction. So I've been taking pictures of Jupiter and Saturn for a couple of years now. So I was looking forward to seeing them in one field of view. This was didn't want to miss this event. And the goal was to capture at least one good shot. Given our cloudy conditions, that would be a bit of I guess an effort, but I did manage to do so. So here's the overview of the presentation. I'm going to go over the location from where I shot the pictures and the pictures themselves and the equipment that I used. I used different equipment. I got out for 3 nights, similar to what Kirby said. And I used 3 different types of setups for each night. So first is the location. I looked at several in-city options, and what I landed on was the Mississauga Flea Market. So the Mississauga Flea Market is on Mavis and Dundas, for those that don't know, and it's got a fairly decent parking lot off to the side of it. And the reason I chose, I have observed from here before, and the reason I chose this is that it's got a very western-facing viewpoint from here. There are a lot of buildings, but the buildings are very low. So it gives you a very nice flat horizon. And I've had a few times, I've gathered some people there to look at the night sky, and it's good for bright objects, such as the moon and the planets, and not good for DSOs, obviously, because it's in the city. The cons are that there's a car dealership right here, and car dealerships are known for their bright lights, and this one is no exception. So this gives you an idea of the flatness of the view. So this was back in May of last year, and this is a very, very young moon, a day-old moon. And usually these moons hug the horizon very closely. So you need a very flat horizon to see it. And I was able to catch it the next day, and the key reason was the buildings are very flat here, and the view is very good. So it's good that you don't have to travel too far to have a fairly decent sight at some of the bright objects in the sky. The cons are the lights. Now, this image is a little blown out. It was taken by my phone, so you have a bit more reflection than what you actually see. But if you zoom in, even on this image, you can see Jupiter right above the lights there. And on a higher resolution image, you can see Saturn there as well. So it's not as bad as it looks here. The sky, when the planets were up here, they were tracking down this way. And even when they got up to this area, they were still quite viewable through the telescope without much obstruction from the light. So overall, I think I scouted this site and I thought this would be a good location where I could get to fairly quickly. So the first night I went out was the 14th. And this was more of a scouting trip to see if how the site was fit for purpose, how the things would look with the sky, and where the planets would be configured in relation to the buildings there, and how they would track across the sky. So more or less just get a lay of the land. And with me, I took my T5 DSLR, which is a crop sensor DSLR from Canon, and a Nikkor 180 prime lens 2.8, which is a really good lens for those who want a sharp, fast lens for astrophotography. The image it produced was standard fare. You have Saturn on the top here, Jupiter down here, and if I zoom in, you can see Titan in the Star Trek TNG font. You can see Titan just below Saturn, blown out there. And Jupiter, you have Io and Callisto and Europa fairly close together. They're barely distinguishable, but they show us two distinct humps in the high resolution image. So it gave me a good idea of the field of view and what I should expect in terms of a week before the actual conjunction. So the main thing is, if you want to get a good picture, it's all about the planning, because the last thing you want to do is be fumbling around in the dark. So, and that's the last consideration, the last thing you need at that time, because so many things can go wrong. The last thing you need is where you want to go and how you want to set up. So the next night I got up was the 17th, as Kirby mentioned as well. And this night I actually was a little lazy. I stepped out of my driveway and I looked up and I could see them clearly, and I didn't expect to see them that clearly. So I ran inside, dragged out my 8-inch Schmidt-Cassegrain telescope. I wasn't very sure of if they would fit in the same field of view of the LX90. So I put on my 6.3 focal reducer and put the T5i at prime focus, meaning attached directly to the telescope. And given that I was rushing around and trying to get things done, I was quite pleased with the way this image turned out. So if you can see here, Saturn is fairly well defined, and you have one of the moons, I believe is Tethys over here, and Titan is just barely visible there as well. Down here you have Jupiter with 3 of the Galilean moons. This is, I believe, Callisto, Ganymede, and Europa. Jupiter itself, though, was a little fuzzy, not so much visually, but because the planets were setting fairly quickly. So this was right on top of the roof of a house. And because of all the heat coming off the roof, it led to some degree of instability in the air. But this was my first view of them within the same field of view of the 8-inch. And as you know, pictures don't do the actual sight justice. And that was quite a sight, because you could see the moon sparkling and you could see the different details on both. And it was a low magnification, but it was still quite stunning. The next night was showtime. This was December 18th. I got to the flea market fairly early. I got the 8-inch set up, and this time I took my prime, my full frame camera, the 6D, and I put that at prime focus. So the 6D is a better camera in that it is more sensitive and it has much less noise. So it captures better pictures that way. And a key component also was an ADC, an atmospheric dispersion corrector, purchasable at your local and friendly Ontario Telescopes dealer and other friendly dealers as well. And this basically corrects for the fringing that you see. So as the objects get lower in the sky, you have more diffraction of the light, and that's why you get the red on top and the blue on the bottom. This doesn't fully compensate for it, but it does help quite a bit in terms of eliminating that fringing. So this combination produced the best result. This image here is a combination of 4 different exposures. So because each of the objects here are at a different brightness. So one for Saturn, one for Jupiter, one for the moons of Saturn, and one for the moons of Jupiter. And this is the same picture, but blown up here. So you have 5 moons of Saturn were able to be captured in the different exposures: Tethys, Enceladus, Dione, Rhea, and Titan. Titan you can obviously see is bigger, biggest moon of them all. And then the 4 Galilean moons, you know, Callisto, Ganymede, Europa, and Io hiding behind, getting close to Jupiter. And as a bonus, I was also fortunate to see that the Great Red Spot was transiting Jupiter as well. So based upon the different exposures and the clarity of the image, I was able to capture that as well, which was, again, a very nice bonus, unexpected. So I was happy that I got the shot that I wanted. And also the Saturn, you can see, as I mentioned before, the fringing is mostly gone, and the sharpness of the rings against the planet, you can clearly see them crossing the planet as well. So at this low magnitude, I was fairly pleased with what I was able to capture. Now, there were a few friends that wanted to see it as well. So I was aware of that. I didn't want too many people there. So I invited about 2 of them, and they had their children with them as well. So here you can see my friend's daughter dressed up as a rabbit or a gerbil or something, looking through the scope. Hopefully she'll get to see it the second time around in 2080 as well, and can remember this site. I also had my binoculars set up that on a separate tripod with a tracking mount. So they could look, people that were waiting for the view through the scope could also look at other objects. So the funny thing, we were observing, and then 2 people from the dealership came by. And I guess they were curious that we had this big telescope pointed towards their dealership and what was going on. Either we were the competition or we were doing socially distant window shopping. Well, they came by and they took a look, and we explained to them what was going on. And they were quite impressed. They were shocked that they could, they wanted to run back and get their kids, but I told them I'm not going to be here, and the plans are setting pretty quickly anyway. So they were quite amazed. And we had one of the friends bring hot chocolate as well. So we stayed there for a while, and I also gave them a brief tour of the moon. The moon was very distinct with its craters, and Mars was also up as well. So they got a good look at Mars. So overall, a good time was had by all. And I consider myself fortunate to be able to have captured Jupiter and Saturn and seen the conjunction with my own eyes as well. Thank you. Any questions?
Thanks very much, Shakeel. Any questions for Shakeel with those excellent photographs? That was, those were tough to photograph given the altitude. You had to have really, really clear skies and a nice low horizon.
Yeah,
If I could ask a question of Shakeel. Shakeel, I love your photographs. They're amazing, and I've got an 8-inch scope, and I don't see what you see, and I guess I'm wondering technically, are you obsessive in terms of collimation, or how do you get such clear photographs? It just amazes me.
Collimation is, I collimated maybe every 10 times, 5 to 10 that I go out. The 8-inch Schmidt Cassegrain doesn't require a lot of collimation, as long as you don't bang it around. But I collimate it, spend about half an hour collimating it, and then I don't really have to touch it for, again, 5, 10 times out. The camera that I use for planetary photography is the ZW-ASI 224MC, the color camera. And I've asked around. I don't, at this stage, I'm not interested in doing RGB on a monochrome camera. And I've been told that the 224MC is a very good color camera in terms of producing comparable images. So a lot of it is trial and error. And this time, for this, the lower the power, you have a bit more things to play with. But on the higher powers, collimation is important, but also sometimes I think to get a good shot, you have to go out as many times as possible to get that shot, right? There are times where the sky is so terrible, it's like looking into a river. And then there are some times where it's still as like a pond. And there's been some occasions where with the telescope, I've looked at Saturn, and it's literally, you think that you're in a spacecraft floating right near Saturn. It is just the most incredible view. You see the different colors of the rings, you see the banding on the planet, and then within half an hour, it's gone. So those moments are what kind of bring you back in the cold nights. But yeah, the more you get out, the more chances you get, the more chances to take pictures and just take advantage.
Okay, great. Were you going to show us your video?
Yes.
Okay, that'd be super.
So let me see. I'm not a big user of such screens here. Let me stop sharing this and switch over.
So with all these great presentations, by the way, presenters, take a look in the chat room for notes from people about your talks. There's some really nice notes there, and all well deserved. So for our next potpourri, I think people should start to think about what you might want to present. As you can see, there's some really interesting and varied presentations. But I think we'd like to see more people give shorter presentations on various aspects of your observing projects or your use of various equipment, or just even some a tour of a constellation or some dark sky objects or deep sky objects that you've seen. And it's very easy to present, as you can see. Whip up your screen and show us a few photos, and you get accolades from everyone else on the meeting. So definitely start thinking about our February 12th meeting, and we'll be asking for volunteers very soon. All right, Shakeel, it's all yours.
Okay, so since Hale Bopp, I was always keen on capturing a comet on film. And as I mentioned before, planning to get a decent picture. So this time around, I made sure I slowly gathered the equipment so to not attract too much attention at home. And I got the equipment together and I decided where I needed to go. So I looked at this site, this Dark Sites Finder site, and I planned out my evenings. So here you have 410, and I decided I needed to get out of the city and into an area where it would be dark enough where I could start seeing the comet without too much background light pollution. So this is 410, and I snuck out just above here to this orange area. The next time I went out more to this yellow area, and then beyond that into the green area. So I just went and parked at the side of a road, set up my equipment, and it was me and mostly the coyote backs. And once in a while, you'd get a few people out there as well that from various areas that would be looking for the comet as well. So I used to go out at around 10 o'clock, 11 o'clock, and then be back just before dawn. And in this way, the pandemic kind of helped because I didn't have to go back into the office. So I could do that. And I was able to put together a whole bunch of time lapses and pictures, which I've been into time lapse photography for the last about a year and a half. And I put together this time lapse of Comet Neowise and released it, I guess it was December 31st. And I'd like to share that with you.
Okay, we don't have sound.
There's no sound at this point.
Oh, okay, sorry.
Let me know if you don't get sound after the text.
Awesome.
Thanks.
Yeah, very nice. I've put the link to the video in the chat room so that you can watch it and crank up the music and enjoy it on your screen at home. But that was amazing. It was such a great comment, and you really captured it well. Congratulations.
Thank you.
Any questions for Shakeel's presentation there?
What kind of equipment did you use, Shakeel? Especially in the
For
video.
the video, I used the Canon 6D, the Canon T5i as cameras. I had 50mm 1.4 Canon lens, a 135 lens, and two 14mm wide-angle lenses for the wide field use.
And for the shots where you got the ionization trail, I assume you were in that green zone. And for those shots, what was the exposure time, and how many did you have to stack?
Exposure time for the ion trail was about, for those pictures, was about 20 to 25 seconds. And I stacked, I believe, around 20 images for those.
Good stuff. Thanks a lot. Excellent work.
Thank you.
Shakeel, where were the,
Yeah. No, go on.
where were
Go
the
on.
pictures with the northern lights taken?
That was in one of those green zones. I just happened to notice there was a few people out there, and there was a forecast for the northern lights. So that was about an hour north of Mississauga, on the side of a road. And I noticed some people there, so I parked beside them, and then I noticed the glow on the horizon. And then when I started taking the pictures, the colors started popping up, so I knew there was an aurora happening at the same time. So again, that was fortuitous, to say the least.
I just want to comment on your photograph with Neowise reflected in the lake. It's just so dramatic and so stunning and amazing.
Thank you. I saw in Google Maps that there was a little lake there, so I tried myself to maneuver myself in front of that and the reflection. So
yeah, that is something else. Yeah, spectacular.
Well done. So I read yesterday about a new potential comet. Does anyone know much about Comet Leonard? Named after the character in Big Bang Theory, I guess, or whatever. It's supposed to be visible all summer long around the Big Dipper, but then it's supposed to get up to possibly third magnitude by the end of the year. Now, we all know that comets are made to disappoint, but something to look forward to. Maybe another, this comet, I think, got brighter than what they expected, so you never know. Okay, thanks again, Shakeel. That's excellent. Always a treat to see your photos and your video. And Alan suggests that we look up Unshakable on YouTube, and Shakeel's got some other videos up there as well.
thank you.
All right. Our last presenter tonight is Fred Benedikt. In the last issue of our newsletter, Messenger, Fred wrote about how easy it is to hunt for meteorites, or at least not necessarily easy, but you can do it. And he's expanded his presentation with some photos to talk about how anyone can own their own meteorite with a bit of patience. So it's all yours, Fred.
All right, let me share the screen here. Oops, share. And let me go to the right page. There we go. So now, hello everybody and Happy New Year. And I guess I'm the one who always gives something a little bit different. So as Randy pointed out, this is an expansion of an article that I wrote in the Messenger, I guess the September issue. And really it all started for me when I read an article in Sky and Telescope in January of 2017 about this gentleman who started this project Stardust, whereby he was looking for micrometeorites. And he became sort of a world-renowned expert on it. And that sort of intrigued me, saying, well, if he can do it, I can do it. Because his claim was that micrometeorites are everywhere, and they actually are. So you have a good chance of finding them with patience. So here's the outline. So this is an expansion on a book report. And I'm going to show you my results because I actually did try it. And I have, like all things for me, I always have more things to do because I still have to refine things. So these are John Larson's 2 books. The first one on the left is something that he wrote in about 2004, 2005, whereby he generally created a nice, lovely coffee book on all types of micrometeorites and facsimiles thereof. And it's a glorious book, but he didn't give a lot of details as to what he actually did. So the book on the right, he wrote in 2019, which actually gives a lot of detailed information so that you can do it yourself. And that's really what I'm going to talk about. So John Larson's background, believe it or not, is a professional jazz musician, and he turned into a citizen scientist. And his interest in micrometeorites started in about 2010, and he's now the leading authority on the topic. And it actually was sort of a serendipity event. He was sitting on his porch having a coffee when a small micrometeorite just landed on his table. And that's what intrigued him. And traditionally, scientists always collected micrometeorites from deep sea sediments or out of polar ice. And John Larson's breakthrough came saying, I should be able to find these everywhere in urban settings. And this is what started his project Stardust. And today he's doing research with the University in Oslo, and actually University of London too, on trying to get more different classifications of micrometeorites. So as he pointed out, micrometeorites are everywhere. The Earth globally receives about 100 tons of material a day, and the vast majority of it falls into the 0.2 to 0.4 millimeter range. So there's a lot of micrometeorites around. And based on the calculation of 100 metric tons a day and taking the surface of the Earth into consideration, it really means you should find 1 micrometeorite per square meter per year, and you'll get a better understanding of what that means. And I really don't understand his table on the right here, because he's saying the distribution for micrometeorites is in the small range, 0.2 to 0.4 millimeter range. You get a little bump at 1 centimeter, and then you get a big rise in the 10 meter meteorites. And boy, if we had a lot of 10 meter meteorites, we'd know about it. And we don't. Anyway, here's the challenge. The micrometer is the size of a pinhead. So it's about 0.2 to 0.4 millimeter, 200 to 400 microns in size. So it's about twice the thickness or 3 times the thickness of a human hair. So the only way you can actually see that is with a microscope. And here's your challenge. It can come in all sorts of different shapes and sizes, and it really depends on how it interacts with the Earth's atmosphere. And you'll see in the next slide what that means. If the micrometeorite, or a meteoroid, I should say, is going against the rotation of the Earth, it gets more friction, which means it heats up more, and then it'll have a more smooth surface. If, on the other hand, the meteoroid goes with the rotation of the Earth and the atmosphere, it has a very low temperature. In fact, it may not even melt at all. And then, of course, you could have somewhere in between. And the shape of the particles depends on really the temperature. The higher the temperature, the smoother the surface. The colder the temperature, the rougher the surface. So generally, most micrometeorites are spherules. They're sort of circular in shape. But as I say, not all spherules are micrometeorites, because you could also get spherules from volcanoes, lightning strikes, and different human industrial processes, such as, grinding or welding. And the author really provides you with lots and lots and lots of pictorial examples. So here's how you gather it. That, by the way, is John Larson on the right. So you gather it. Most micrometeorites have some kind of metallic content. About 80% of them are metallic. So you just get a strong neodymium magnet, and you can put it in a little baggie, and you can start trying to pick up things, which is not very efficient. There's a better way of doing it here. What the author suggests is you look on flat roofs or gutters, or here's the key, any undisturbed surface. And that sort of is a key indicator. If you've got a surface that hasn't been disturbed for 10 years, and you got 1 square meter of it, theoretically, you should be able to find 10 micrometeorites in. He also talks about how you clean it and store it and document it. And his suggestion is that if you get about 300 kilograms of material, you can find about 500 micrometeorites. So it's not exactly a needle in a haystack, but it does take some effort. And of course, you're going to come across some other interesting objects. So the handling, well, because it's a pinprick, you basically have to handle it very carefully, and it becomes a challenge how you separate everything out from. And the author suggests using, toothpicks, and to use a toothpick to transfer it to your microscope slide from your container. And you'll see a little bit of that after. And this is what he's basically working on now, is more different classifications. And he has 4 broad classifications for meteorites. So he gives, of course, numerous examples in his book, and each of these 4 classifications is broken up into other classifications further down. So here's your challenge. How do you verify if you got a micrometeorite? Well, technically speaking, there's only one true way of knowing if you found one. That means you involve your local university, you get access to their scanning electron microscope, because remember, the surface is temperature dependent, and if you have a smooth surface, it's one thing. If you have a rough surface, it's another. And your scanning electron microscope will give you a better clue of that. Then if you get that far, you might as well ask for the world. So you might as well ask access to their mass spectrometer, because now you need to do a chemical analysis of the actual particle that you have, that you suspect. And more importantly, you have to look at the altered isotopes of those elements, because remember, if it's a true meteorite or a meteoroid, it was in space, and radiation alters the properties of chemicals. Now, if you're still with me, all of that with the mass spectrometer and the scanning electron microscope, you can throw all of that information away if you want. And you can just compare your samples with the pictures in his book, which is it's called Looking at the Morphology. So he gives lots and lots of examples, lots and lots of pictures, and you'll end up with things that look like that if you clean them properly. Now, the challenge is also, how do you document all of this? Well, he gives some suggestions, because he's found thousands of micrometeorites. And he's got this special camera here that he's set up, whereby it goes up and down on the vertical z-axis in 1 micron increments, because when you're looking at a very magnified image, you have a very narrow depth of field. So the image is only sharp at one point. By stacking a whole bunch of images, he then gets these lovely little displays that you see on the right here. Now here's my attempt to collect. I take the lazy way out. I just went to my gutter downspout. I got some neodymium magnets. I got some little gem jars, put the magnets in and plopped them down and picked it up after a couple of good rainstorms. And you can actually see some of the material is gathered here. And then you basically try to separate it all out, and you'll find that it actually is magnetic. And actually, if you can look very carefully, there is a larger object here, but it takes some patience. And my second attempt for collecting was a little bit more ambitious, where I actually started to clean the samples, because during my first collection, I hadn't read John Larson's second book yet. So after reading the second book, I started to clean my samples, and he goes into the process of how to do it. And basically, you also separate things out if you can, if you have a filter, which I have, and then let the sun evaporate the liquid out, and you get some material left over. You have to select the material that you're sort of interested in. You put it on some microscope slides, right? And then you put it on some kind of a microscope. So this was my kind of proof of concept, whereby I borrowed back a microscope that I gave to one of my grandsons, because it happened to have a video output, and I connected that to my computer. And it just proved that it can actually work, but I didn't have, well, the results were there, but I was losing samples, and you'll see why, because things are so small that you can breathe and you blow it away. And you see here's a case where I dropped something, but in other cases I dropped it on my workbench and it was gone. Couldn't find it anymore. So I improved on that with my second version, whereby I used an illuminator that I have for looking at 35 millimeters film. And this worked much, much better, because if I dropped the sample, it was on a white surface and I can actually see where it was. So that was better, but I still need to improve on that. So here's some of the results I had. So the first thing you have to do is you got to calibrate your system. So in this particular case, this represents 1 millimeter or 1,000 micrometers. And here's one spheral that I picked up, which is about 200 microns. Here's another interesting tidbit, which I call it the whale or the fish. It's about 600 or 700 nanometers, and it's metallic. I picked up this one really interesting thing, which I have no idea, and the book doesn't really have a picture of that. Here you got some other spherals, which are much smaller, but this one could be very interesting because it's a little bit different than the other ones. And of course, you have a couple of really small metallic spherals there, but I don't think they're micrometeorites. I think they're actually from an industrial process, but I have to get some clarity. So what I really have to do is I got to get a better microscope. So if anybody has any leads for me on any kind of used microscope I can get that a university doesn't want or some lab is throwing out, call me, because I'd be interested. And then, of course, I also have to gather some more material because I'm not anywhere close to having kilograms of the stuff. I'm lucky if I have a couple of 100 grams of the stuff. And as part of my other next step, I'm not going to make a very fancy camera system which increments in micrometer increments. I found another source where somebody tried this, and they actually take a video of the sample through the microscope. They rack the focus, and then they take a video of that, and then through software, they select different frames that are sharp and then stack them together. So it kind of mimics this. It's a cheap way of doing it. Because as you see, the samples, you know, have different focal points. And in summary, if you want, there's a little detective kit that you could try. I call it that. It's very informative. The book's very informative on how to do this. It tells you where the best locations are. It tells you which roofs to go to and things like that for success. It tells you how to sort your samples, clean your samples, identify your samples, photograph them, further examine them, and then you finally have to catalog and store them. And I'm trying to do all of that, and I'm having a good time doing it, and I'm hoping that you guys will give it a try on some dark winter night when you have nothing to do. Thank you.
Thanks very much, Fred. Well, we've got a lot of extra time, so yeah, maybe this is a hobby you may want to pick up. Any questions for Fred? Okay, well, thank you. Yes, Fred, you do bring us some interesting presentations, that's for sure.
They're always different.
All right, well, that's the program for tonight. I just want to say a few things before we sign off. Our future meetings. Our next meeting is 2 weeks tonight. It will also be at 7:30, and the speaker will be yours truly. It's coming up to the 50th anniversary of the Apollo 14 moon mission, and I thought I would share with you some interesting things that happened on that mission, the first mission after the Apollo 13 mission, which we talked about last year. So that'll be in 2 weeks. 2 weeks after that is the 12th of February, and hopefully we'll be out of the lockdown by then. That'll be another Potpourri night, and again, think of what you might want to share with everyone, even if you come on for 5 to 10 minutes and show some images or some sketches, or even talk about some aspect of the hobby. That would be great. It'd be nice to have a lineup of 7 or 8 people giving short presentations. And, you know, as you can see from the variety we had tonight, that was excellent variety. Our meeting on February 26th is our annual general meeting, our business meeting, and there will probably be a short presentation for that. But generally, it'll be interesting to see how we handle the annual meeting on a Zoom session. But we need people to come and attend that, so that we have enough people to run the meeting, so that we can talk about the last year, and it was a different year, and just to approve our finances and our upcoming new council and things like that. So that's on February 26th. There'll be information in Messenger when it comes out by the end of the month, with an agenda and a reminder of the date and time, and a link to the Zoom session, and we will see you then for that that meeting. So again, this recording will be posted on the website. We saw a few little issues tonight with delays for people getting in, so we'll try to fix those for future meetings. And if there are are there any comments, questions before we sign off for another weekend lockdown?
Thanks for organizing, Randy.
Sorry, Rob McNaughton here. I'm just curious to know what the software that takes multiple images by video, and then you can combine them together to get the different layers in focus.
It's general purpose software. I just sent you a note saying that I'll email you the specifics. But I can email everybody at the same time. I just have to look at my presentation. It's if you do a look.
Fred, rather than email to everybody, why not just send it to the group?
Yeah, which group?
Everybody here should be on. At least the members should be anyway. Sorry.
Okay.
Yeah, the Groups IO email list. That would be great.
Yeah, it's called Infused GUI, but anyway, I'll email.
Yeah.
By the way, for anybody,
talks, by the way,
for anybody that's not a member, if you want any follow-up information or a link to all of our meetings, they're all posted on our website, and you can all access them. So just reply to one of the meeting emails, and I'd be pleased to send that to you. Okay.
Okay, thank you, John. Okay, so just after 9 o'clock, so thanks everybody. Stay safe, and we'll see you in a couple weeks for a speaker night. If anyone has any suggestions, I'm starting to work on future speakers. So if you have any ideas on topics, then please send me an email. Or through mem meeting or whatever, and I'd be glad to look at it, since we are really just lining up people from around the world to give us talks. Then I guess anyone's possible. So with that, I'm going to sign off. Again, this is recorded, so it'll be on the website in a few days. Take care, everyone, and we'll see you soon.
Right. Take care, everybody.
Thanks, everybody. Great job.
Safe.
Yeah.
Great job. Thank you.
Thank you, Randy.
Great presentations.
Yeah, they were awesome. Thanks to our speakers.
Bye, guys. Bye.
Bye,
Lukash. Bye, Lukash.
Bye.
Bye, Lukash. Yeah, we had 55 people tonight. That was pretty good.